Hello, we're Team 45 and we chose to work on the Intel Challenge. And we looked at the photolithography. We focused more on just the positioning, the XYZ axes, and a little bit of the laser photolithography stuff. And this is our project. Our prompt was to tell us to propose and design a prototype that advances open source chip development using accessible hardware. Semiconductors are really expensive to make. The capital for it is really, really expensive. So we were trying to look at, based on the parts that we were given, how to make semiconductors on our own. We were given the Arduino, stepper motors, stepper motor drivers, and just like a red laser to mimic a actual photolithography laser, since usually they use ultraviolet light and vacuum sealed uh, places. When instead we were just doing a red light because you don't really have access to the vacuum sealer.
The diffracted angle is fixed by the red light wavelengths and the distance between slits on diffracting grating. If the diffraction grating is moved perpendicular to the laser beam, it will provide a trigonometric ratio to the displacement of first-order diffracted light on the screen. As the angle is less than pi/4, movement of the diffraction sheet will provide a smaller displacement of the first-order diffraction.
Our contraption works by moving a laser along the X and Y axes using stepper motors and by moving a light diffractor along the Z axis using a stepper motor. So right here we have an Arduino board powering everything, and we have 3 stepper motor drivers that are controlling all of these. And all of these can work synchronously to move the laser anywhere we want on the X and Y axis, and the light diffractor anywhere we want along the Z-axis, which will change the position of the laser shown on the ceiling.
Fraction of the laser we also put inside a box so it'd be easier to see. In order for it to be a DIY project, it's going to need a DIY budget. So looking at these prices shown here, we can see that's around $123.47 for everything that we used. You could easily make it cheaper by using a cheap Arduino or a Raspberry Pi, which could be cheaper than $50. And then the miscellaneous materials, which is based on the 3D printing, which if you used that more, would be a lot cheaper than the cardboard that we found around the lab. Biggest challenges was trying to get the Z-axis to work because it would like slip off the 3D printed gears. Sometimes we had to add in more walls on the sides in order to have it stay only moving on the Z-axis. All learned how to use the Arduinos. We learned how to use the stepper motors a little bit better, and we also learned a lot about how semiconductors are made. Thank you.